sometimes my engineers wish I would drill in even more. And so we're working together on how to interview a customer to make sure we get all the information we need to specify the product properly. It's a big part of it. If you don't do that part right, you will underestimate the cost and the time involved to get to a solution, and you'll wind up with a lot of rework. To me, success in business is a couple of factors. One, being a bulldog and not letting go. Well, three things. Two, recognizing when it's stupid to be a bulldog and do let go so you don't starve to death.
Right.
And the actual other one is always keeping your eyes open for ways to diversify your customer base.
Welcome to Manufacturing Insiders. We have Doug Wilson, the founder and CTO of Fiber QA. Doug is an overall great guy, just an impressive individual, having, I don't even know how, won countless battles to get where he's at. And, to take a product from idea all the way to formulation and manufacturing, and then to be getting it out into some pretty significant places in the market. He's an inventor, researcher, scientist. There's probably a whole lot more accolades that I'm not able to list off. But Doug, just tell us, how did you get started here? Like, what made you, what caused the idea to invent this product?
Thank you, Nate, for the opportunity to talk about my products and company and life experience. I won't start all the way back at birth, but it's an interesting journey. I had started working as a naval officer, then went to work for the Navy as a civilian, and then a short stint with a DoD contractor, at which time I decided I wanted to do commercial opportunities. So I formed my own company with some partners, and we did custom systems development using products and software from National Instruments in Austin, Texas, now part of Emerson. And what happened as a result is we got involved in image processing. And so we were looking for a product that we could offer the marketplace and hit upon fiber in-face inspection. So this is back in the late 2000 timeframe. And so we first started off offering just a software product working on other people's microscopes. We quickly had an opportunity to pitch that to Cisco Systems, as you know, a major player in the network router space.
Yep.
They asked us eventually to take that software and wrap hardware around it to fully automate the process of acquiring images of multiple ferrules on their products. So around late 2000, we won a fly-off between multiple vendors that Cisco was looking at. And by the end of 2003, we had deployed the first systems. And we used those systems over a period of 2003 to 2019, when the product we were working on went end of life. So we took a software solution and improved it to the point where it was the best in a class in the world. And then we added all of our experience working with systems development to develop a complete turnkey system. And now we've leveraged that to produce 5 basic models of that, all the way from the original floor standing unit to something about the size of your fist that inspects fiber optics on military aircraft and shipboard use. So I guess it was a opportunistic thing, briefing customers on our software product, that led to this. And it's been quite a ride, as you said. It started as a quasi product in a custom engineering company. I thought it had great potential as a full product. Convinced my partners to let me seek outside capital investors to spin it out, and I went with the spinoff, and we've been doing that for about a dozen years now. So we formed a separate company called Fiber QA, And we've been marketing this to both commercial clients and military and Department of Energy clients since then. And I should probably take a breath and let you ask me another question.
Well, no, that's a great summary. I actually do want to rewind just a little bit because I'm interested to hear about, you said you were you started out with the idea that you were going to develop a product from scratch. Like, how did you land on, feral inspection?
Um, that's kind of an interesting segue. That brief stop that I talked about at a DoD contractor. I took a group that was automation systems, was head of that group, and really moved them from, ironically, having come from DoD, from being mostly DoD to being almost exclusively commercial. One of the products that we developed there was a display inspection product because that group had originally started as the first GraphTech distributor, which eventually became NI's vision product. So we had a group of people who were doing vision related products. Well, when I left that company, I couldn't work on display inspection systems. And so I went back to NI and asked them if they had any other vision opportunities that they knew about. And one of their offices in Japan had been working on software to inspect fiber optic interfaces. And so we negotiated with National Instruments to take that project on, take ownership of it. They sold it to us as a fully complete and robust package for in-face inspection. And about a year later, we had it sort of working. And a few months after that, it was really working. And we've continued to improve it ever since. So we've continued to invest not only in the hardware aspects and changing the different models, but we've continued to improve and expand on the robustness of our fiber inspection. So picture that in the midst of a custom engineering firm where we did things like design a system to measure the angle of the grind on the end of a razor blade,
Right.
to measuring hold down tendon tension on an oil rig in the ocean, to end of line vision inspection for thin film solar panels. So we had this plethora of different applications that all had as a common theme that it either did data acquisition or image acquisition and processing using tools primarily from National Instruments as the basis of our business. The problem with keeping it in that company is it's very difficult to do custom engineering and a products company. They really have a lot of differences in the way you run the business, the way you finance and invest in the business are very different. And so, as an example, real world situation, we would be going like gangbusters on improvements and development of the fiber inspection product, and new work would come in that was actually being paid for by external funds.
Yep.
What do you do as an owner? You go
Yep.
work on the thing that's going to bring money in and keep the lights on and the doors open.
Yep. No, I completely can relate to that. We've developed some software over the years, early on actually probably about 5 or 6 years into starting WeCreate, we actually got to thinking about our town and we didn't have a parking app here, just all coin meters. So we decided that we were going to develop a parking app. And, brilliant idea. But we spent the next 2 or 3 years developing this software without ever knowing whether or not the city was going to use it. And so we finished it and we talked to the parking authority and said, listen, we developed this software and it's going to work great. And they said, okay, we'll use it. And we were like, whew. But yeah, I mean, it takes away from the core of what the business does.
Right.
But it also provides a lot of opportunity if you do it right. So just as a matter of definition, so the product that you developed inspects the fiber optic ferrule, which is the kind of the end that plugs into the terminal, and it's like a ceramic material usually, or what is that?
So I think more correctly, we inspect the fiber interface. So it's in a connector, right? So
Okay.
you have different types of ferrules. The main two types, there's a bunch of types, but the main two categories that make sense is a single fiber epoxied into the center of a ceramic ferrule.
Okay.
And there are lots of other types of ferrules. There are, ruby ferrules, there's stainless steel ferrules, but the predominantly used one is a zirconium ceramic. And when the fiber gets inserted and epoxied into this, it then goes through a polishing process to achieve the geometry and the surface finish required to get the optical performance required. So when these two interfaces meet, like my fingers, if I could touch them, the fiber's in the very center of that. And two things are very critical. You can't have any defects on the end that are unacceptable. So you're allowed a certain size or certain number of different sizes. You're allowed a certain number of scratches of a certain width. And these are all at microscopic dimensions. We're talking about things half a micron to a few microns in diameter, and the same thing for the width of scratches. And there are different standards. I've been on committees for setting those standards, like IEC. I've been on industry consortiums that have done experimentation to help define what those standards need to be.
Yep.
I started working with INIMI in 2004 that informed an IPC standard and my screen just went blank. Sorry about that. And also eventually informed the IEC standard, which I'm still involved in. So very critical, very small dimensions, but in our case, because we're fully automating that and we're working on connectors that are mounted inside the connector shell, we wind up using much longer working distances than the typical microscope manufacturer. And just to finish one more thought, the other type of ferrule is the what's called the MT ferrule, and this ferrule is typically a thermoplastic with glass fill, and it will have anywhere from 12 to 72 fibers per ferrule. And so very different. The fiber part, the inspection within the fiber is exactly the same, but doing a large number of fibers in the ferrule produces some complications, which we did some innovation in, which we call our fast MT technology.
Yeah, I mean that's fascinating. So the component that you're actually inspecting is the component that is enclosed in sort of an outer shell. Is that right? Or are you inspecting the outer shell as well?
No, we're very focused, no pun intended, on the fiber and its surrounding ferrule material in the case of single fiber for ceramic ferrules. The real hierarchy that we think of in terms of our product line is we think about a fixture, we think about a part, then we have a definition of a connector, definition of a ferrule, definition of the fiber that goes into the ferrule. So by using this predefined hierarchy, we can build up a definition, including all of the geometry and all of the arrangement of the fibers that's very generic. And we've used that across router cards to mill circular connectors on aircraft. So ultimately, what we're inspecting with our microscope is the 2D surface on the top of the fiber and ferrule.
Okay, got it.
There are other considerations, and it would probably be nice to actually do the surrounding 3D area for cleanliness. But currently, we don't attack that part of the problem, and nobody else in the market does either.
Gotcha. So, just I was trying to wrap my head around the part that was being inspected, and that makes sense. But when you mention kind of the in the field applications, where they can use this, for inspecting the fiber optic connections on a jet, like those connections are already manufactured and enclosed. So it seems like they would have already been inspected. How
Well,
does that?
you're exactly correct. Uh, but here's an interesting fact about fiber optic connections, unlike electrical connections. Again, going back to my finger pointing, if I have light trying to transmit through this connection, and the
Hmm.
reason we have connections, of course, we may need to break it apart to get access or to repair something. But once I make these two fibers together, if I have anything in between those two paths that blocks the light,
Right,
then I won't get signal transmission.
right.
So it's an occluded area problem. If I occlude the area of the core of the fiber, then I at best get a higher bit error rate, and at worst, I block the path altogether and the system ceases to operate. So in a typical commercial environment, in a data center, for example, those connections are made and nobody ever touches them. So once you inspect it right before you made it, that's it. You don't need to do anything with it until you replace the equipment. Um, like in a central office for a telephone network, they may stay mated for 30 years. Data centers probably gets refreshed more frequently because they update we go from 10G to 100G to 1 terabyte per second. In a military situation, you've got other factors. You have vibration, you have pressure changes as the aircraft goes up and down, you've got temperature cycling, you've got the pilot yanking G's on everything. So those have different requirements. They also tend to open the connectors up more often for removal of it because it's interfering with getting to some other part that needs to be replaced.
Okay.
So the rule is anytime you open a fiber optic connector, you should inspect it at the very least, clean it if it's contaminated, re-inspect if you cleaned, and then you do that on both halves of the connection, and then you can remate it.
Gotcha.
So that's why military and other like transportation related uses, the connectors might get opened up a lot more frequently and need to be re-inspected in the field.
Right. How many of those types of connections are on an aircraft?
Well, I could tell you, Nate, but you know what I'd have to do then, right? So,
Are we talking hundreds,
well, it
dozens?
depends. I mean, there are some applications that have thousands of fibers on a system on a particular platform. Some there are not necessarily very many, but they're part of the avionics package or the sensor package on the aircraft, and so they're very critical to the mission. Um, it really just depends on the particular system.
Gotcha. So it seems like you're pretty hyper focused in the aerospace defense sector. Given the wide range of applications for fiber optics, why is that kind of your focus? I mean, from what we talked about before, there's a lot of barriers to entry in dealing with the government. You could say.
Yeah, those certainly are. Um, it's being opportunistic. We started out commercial. I think we kind of saturated the market in terms of high volume applications with companies like Cisco and Juniper Networks. Um, and then as those cable assembly, part assembly, OEM kind of opportunities started drifting down, I wasn't happy with not continuing the business. So you continue to look for other ways you can be successful. To me, success in business is a couple of factors. One, being a bulldog and not letting go. Well, three things. Two, recognizing when it's stupid to be a bulldog and do let go so you don't starve to death.
Right.
And the actual other one is always keeping your eyes open for ways to diversify your customer base. And so as we actually had an opportunity that was, from our point of view, a commercial cable opportunity, but it turned out they were making these cables for a military aircraft prime.
Oh,
And the military aircraft prime finds out that, hey, their manufacturer of the cable is using this really cool hardware. In fact, that customer would put us on their tour when they would have their bigwigs from their customers come in and say, hey, look at this neat tool that we're using that does all this inspection automatically.
yep.
And so our word spread, and so we got asked to talk to them about their needs for assembly plant when they're installing the cable harnesses on the aircraft. And so it was kind of a fortuitous blessing that we received to have our business go in a direction that would continue to promote our growth and allow us to develop some new versions of the technology repackaged. I jokingly say our big unit that Cisco would willingly bring, hundreds of cards a day over to it to inspect wasn't going to be very useful on the assembly plant line because they're not going to bring an F-35 over to that box and try to plug in the optics to it. Just not going to
Right.
happen.
Right.
So you have to take that great big thing, bring it down to something the size of your fist so that it can go up inside wherever these connectors are located. So
Yeah. Wow. I just it's just a whole new world to me, like how you even take something from this idea to developing the software and the technology and you know the team behind it and how do you I guess what was kind of your first step after you said, okay, this is what we're going after. We're going to develop this product that inspects the ferals. What's the next step there? What do you do?
So one of the things I've been blessed with is an ability to listen to a customer, explain their needs and their pain points. I've got over 45 years now of engineering experience. And when I started in the dark side of sales and marketing, I had about 20 years. So, I've had about 25 years where I've been a mix of engineer and sales. And the sales side, is really about listening to what the customer is really concerned about.
Right.
Are they worried about improving their quality? Or are they worried about reducing life cycle costs, labor cost in assembly? Is it wall clock time? Is it just increasing the throughput so that they're getting better utilization of the rest of their process? There's all kinds of reasons that customers have for wanting to automate a process, specifically when you're trying to automate. And so I basically just listen to what the customer wants. If I have expertise in that area or my company has expertise in that area, then we would go and do it. That's why the custom engineering business that I did for a dozen years was very successful because we could rapidly respond to widely varying applications.
Right.
And then I've been fortunate to have really good partners and employees who have the talent required to take these harebrained schemes that I come up with on how to solve the problem and turn it into practice, turn it into actual hardware and actual software that performs as well as the customer needs it to. So it's a combination of vision, uh, ability to listen to the problem and translate that into a solution that we either already have or that we can develop. And then great, just providing great support for the customer. We work very closely. In fact, I'm working on a major application now that just finished up a support call with our customer. We're in the process of integrating this into their system. And, that always comes with a series of growing pains. And so you got to be willing to respond to the growing pains and work with your customer and get your customer to work with you as you go through those refinements that get it from a concept to an actual use.
Right, right. So you got to understand the problem. Um, just physically though, kind of what I was driving towards, just from somebody that has never developed a physical product. What do you do then? Just make a 3D model of what you think it should look like, a napkin sketch, and then start to analyze the functionality. Do you do that before you do the software side of things? Like, how does that work?
Um, it, it actually depends. Most of the systems that we work on, excuse me, have a large component of it is hardware. Just think of it this way. I go from a box that has a camera system and cleaner system that's, this volume. And now that volume won't even fit in I'm going to shrink that down to a fraction of that size to fit in the space available. So now I've got to really engineer the product. And that involves, the 3D modeling, both physical, 3D printing things so you can get a sense of the size, but of course, first modeling it. And our engineers like to use SolidWorks here.
Hmm.
Um, they're kind of happy that I haven't had time to learn how to use SolidWorks because then I'd be interfering with them even more than I already do. Um, but seriously, it's interacting with engineers who have the skill set to listen to what you want in terms of what the thing needs to do. And I found oftentimes the biggest problem I have with my engineers is I think in terms of how to do something a lot more than I think about what it needs to do.
Hmm.
And so what I really need to communicate with the engineers is this is what it has to do
Right.
and give them the flexibility to determine the how. So that crossover between your vision of what you want it to do and how to actually implement that, I'm still enough of an engineer that I'm intimately involved in that part of the process as well. So, and that's fun. That's what makes it, fun to come to work every day. You get together with some really smart people. You do sketches on the whiteboard. One of the talents I do not have is the ability to draw very well. But our head of ME can throw up a 3D drawing on a whiteboard just like that. I mean, he's amazing. Um, some engineers I work with, while they're interactively building something in SolidWorks as I'm trying to describe it, and then we kind of bounce ideas off of each other. Other people want to be told basically what to do and what size it needs to be, let's say, and then they go off and implement one, two, or three options for it, and then you iterate on that.
Right,
So
right. That's very interesting. So is this?
software has to be an integrated part too, just to answer your software part. I'm sorry for interrupting you, but um, when to bring software in and hardware, that's always a challenge, because it's a chicken and egg problem. So the software guys need to tell you what's possible from their side, both firmware, the real low level driver stuff, talking to motors, talking to cameras, talking to LEDs, um, and then how to package that together. Another interesting thing is we had one case where we had to actually have someone work with us to design the optics to fit in this very tight space. And
Mhm.
so now we had an optical designer who's working on the optical properties that we had to team in with our mechanical designers to make sure those two things fit together.
Right,
So it's just it's like any other multidisciplinary problem. You got to bring the right disciplines together and let them work in their own space to do their own part of the problem, but then also to work on an integration basis to pull it all together to get the functionality that you need.
right. Yeah, I love the idea that you're able to take something from an idea and turn it into a product. And just talking to people through my whole life, there's so many people out there that have ideas for things, and they have this idea for this great product, and in 99.9% of the time, it never goes anywhere. Is this if somebody comes up with this great product idea that maybe integrates software and hardware and wants to find a way to bring it to market. It sounds like you already kind of had a lot of these resources at your disposal. You had the engineering team, you have, the 3D printing capabilities and things like that. Is there any path for someone like that to actually
Well,
bring a
you got to
product to
pull
market?
all that together. I mean, I didn't have all that stuff. We generated all that stuff as we needed it. We
Right.
hired the right talent. Uh, the 3D printing is kind of interesting. I had my mechanical engineers a few years ago came to me and said, "Hey, we've been seeing this really cool, really low cost 3D printer, and we want to buy one." And they were ready to full court press me to authorize purchasing this printer, right? To the point where they said, if you're not going to approve it from the company, we're going to pull our personal money and go buy one.
Wow.
And I'm like, no, well, of course we're going to buy it. It's an easy decision. Now we have 4 or 5 3D printers in the building,
Wow.
different technologies from fluid to melted wire. Um, and it's remarkable what they're able to do. Now, most of those parts are prototype quality only. They're to determine right form, fit, and function. Um, the low cost 3D printing that we do is really not um, something you want to use in most production parts. So we've also, in addition to doing 3D printing on our own and learning all of the intricacies of doing that, because
Hmm.
it's still art to some extent. Um, we form relationships with people who can do production parts for us. So there's some different companies that we work with to take those prototype parts and those designs and do a little bit of finish work on the design side, and then selection of materials with the right properties and doing the right post production, post 3D printing processes to get
Hmm.
the quality of part that we need for a production part.
And are those mostly going to be like machine shops, or what sort of third parties do you?
There's specialty companies that specifically specialize in 3D printing with lots of different technologies.
Okay.
They're that's their whole business is 3D printing parts.
Okay, so you're
Um,
making a rough 3D printed part, and then you're having somebody else make more of a refined 3D printed part. Okay.
Correct. That has the right mechanical properties, the right finish quality, and they're set up to handle it in the volumes that you need. And this, in our case, is still pretty low volume. And then beyond that, when the volumes start to pick up, then you start converting to molded parts or cast parts. And, in some cases, 3D printing is still going to be the most economical thing to do. So you got to pay attention to the business side too. I mean, we've been talking
Right.
about all the engineering and, design aspects, but ultimately you have to produce a product at a cost that your customers can afford, taking into account the margin that you want to make from the business side.
Right. I wanted to jump back just a little bit to what you were saying about, kind of asking the right questions and identifying, exactly what the need is of the customer. Because there, I noticed in a lot of cases there's confusion on both sides because a lot of times the customer doesn't clearly state what their problem is, or they think that their problem is something that it's not. And then the guy that's listening, the guy that's on the sales end of that, a lot of times just accepts the first answer. So, what's kind of your process for drilling down a little bit further and getting the right answer, actually finding that, black swan, if you will?
Sure. So if you think back about some of our interactions, the conversation doesn't go very long before I'm asking questions or
Right.
offering opinions, right? So it's a personality thing. In my case, I can grasp the big picture pretty quickly. Sometimes maybe too quickly, and I just ask a ton of questions. I have enough experience doing this now that I know not to take the first answer I get. I have a sense of where to stay very high level and where to drill in. Um, and sometimes my engineers wish I would drill in even more. And so we're working together on how to interview a customer to make sure we get all the information we need to specify the product properly. It's a big part of it. If you don't do that part right, you will underestimate the cost and the time involved to get to a solution, and you'll wind up with a lot of rework.
Right.
So um, that's a real artsy part of the business, how to get the customer who may not themselves understand how important some of the details are. And they may not even fully understand the basic problem they're dealing with. Um, they may not be the person who came up with the idea. They may just be the person assigned the responsibility of doing it. So they may not be that
Right.
uh, well informed about what their company is trying to do.
Right.
And if it is someone who's dreamed up the idea on their side and they're looking for engineering help, like some of the companies I've gone to, we don't do all the work inside, the optical design, for example. We didn't have the in-house expertise to do that, and it didn't make sense to develop that internally. So we had to talk to someone whose language we didn't understand.
Mm-hmm.
I don't understand optical properties. So when you think about it that way, you think, well, my customer that I'm talking to probably doesn't understand my language. He doesn't understand the image processing process. He doesn't understand how I need to get the tolerances on the mechanical parts, or how I need to know the volume I can work in, um, enough to answer all my questions. So you just have to find the right way to interview them and get that information from them. And
Right.
sometimes it's not just me, of course. I need to also understand, when do I bring my experts in that know a lot more than I do about a particular part of a problem.
Mm-hmm.
So, if you do that too early, you spend a lot more money than you want to in the proposal phase. If you do it too late, you become a big filter. And in some cases, all the right information may not flow between the customer and our inside engineers.
Right. I would imagine after you get your product on location and in a lot of facilities, eventually, even if the customer doesn't understand the fiber optic or the imaging side of things as well as you do, or as they need to, a lot of times I guess you don't even need that information anymore. Like, you've already seen this problem before, and you have a pretty good idea of what their problem is, and can probably solve it without even too much feedback from them.
Um, yes, I mean, there's always going to be a product specific part of the application, or subtle differences. We try to make our software very flexible to allow the customer to define the inspection criteria, for example, to meet whatever goals either maybe their end customer wants. I mean, we're working with a company now who we're in pre-proposal phase on a product for a space application. So when you're going to put something on a rocket, that's a different level of requirement than, say,
Right,
fiber optic that plugs into the back of your TV set from the pole out on the street, right?
right, right,
Um, yeah, you don't want that thing that's going to fire off uh, the rocket motor at a certain time to fail because you didn't inspect the fiber correctly.
right.
Uh, so yeah,
Did you
it's
see the? Did you see? I saw this video recently. It was so cool. It was an animation of the number of rocket launches over time. So they'd go like 2000 whatever, and then they moved all the way to today. And it's incredible. There's just
SpaceX. you're talking about the
unbelievable.
SpaceX facility and
Yep.
the density of rocket launches. I mean, SpaceX is a phenomenal success story. Think about it. This guy is risking billions of dollars and he's willing to share with the entire world his failures along
Mhm.
that journey. Most of us hide our failures, jealously guard our failures, right? We don't
Right.
want to talk about our failures.
Just look at the
Uh,
U.S. government.
well, yeah, that's a whole different.
That's a whole different level of
That's a whole different. We might
dishonesty.
want to. So, but one of the things I'm impressed about Elon, for example, is he said at the beginning we're gonna have a lot of failures as we go along, and we're gonna show those to everybody, especially ourselves, as much as we show our successful rocket launches, because that's how we learn. And he's built this company now that just keeps launching rockets at a faster and faster pace because he's driven the costs down and the need to access space has become so critical. It's just amazing how many satellites we need in orbit around the Earth. It's
Right.
just look
Yeah,
at
I can
Starlink.
attest.
They launch hundreds of satellites at a time.
Yep.
So
Yeah, and I can attest to the value of that. I live kind of out in the country, and the only internet we could really get there was like HughesNet, which they have big data caps and it's pretty unreliable. Finally, I was able to get Starlink, and it's incredible. I mean, I get super fast internet upload and download speeds, and yeah, it's great. I'm so relieved that he created that.
yeah. So is
But
Ukraine.
yeah, yeah, I guess so, right?
Uh,
Yeah, I'm impressed with the guy too. I mean, there's people that criticize him, but I just even think that his desire for transparency is played out in his purchase of Twitter, now X, and I think it's a great thing. I mean, because when you
right.
have all of your media, all your social media outlets owned by the same people, censoring the same people, you need a breakout. You need some truth somewhere. So
Yep, I
impressive.
agree.
Yeah. So your current target market is the U.S. government and the prime contractors. Is that fair to say?
That's fair to say. I would say I haven't given up on some commercial opportunities, both commercial aerospace, but also commercial like data center installation and maintenance. I would say the biggest change in our company that I want to have happen is a move from the relatively small volume, at least small volume per customer,
Mm-hmm.
of the OEM manufacturing assembly side to
Mm-hmm.
the long-term operational level sustainment side. So, so making that transition from selling, say, 5 or 10s or even 20 units to a particular program to selling to a program like the F-35 program, for example, where individual squadrons need to do the same kind of maintenance on their fiber optics that we're doing in the installs.
Right.
The the advantage for me for us as a business is the volume of sales. You're going from tens of units to hundreds or thousands of units, and then multiply that across a lot of products. So the home run for us from a business standpoint is to penetrate the sustainment or maintenance market where the volumes of units and the volumes of the consumables for the cleaning process become very significant.
Gotcha.
So,
How quickly can you scale that manufacturing process up?
yeah, I raised my eyebrows. So that's a big question, right? Because if you're not prepared, and you won't know if you're prepared until you actually try to do it,
Right.
you've raised this interest level in the market. I liken it back to when Apple came out with the iPod. You know, that product didn't exist And all of a sudden they've created all this interest in the product. And if you don't take that gamble to get ready for the production side, which they were unfortunately had the investment capital to do, you could miss your opportunity, right? So you got to be ready. We're still debating whether that's a ramp up our own internal manufacturing or continue to be an R&D and prototype arm that supplements our capacity with contract manufacturing.
Right.
I suspect it's going to go the latter route because that's more scalable.
Yep.
Yep. It just remains to be seen.
I think that the contract route works really well for a lot of people. Obviously, you lose a little bit of control over the manufacturing process, and you lose a little bit of margin on the product. But certainly, if you need to sell quickly.
I mean, it's a question, right? I don't have experience with it yet. I'll say that. I mean, I've watched other people do it. I've worked with customers and supported their contract manufacturing. So I've been in both large CMs in the U.S. and overseas, Thailand. And it's an interesting process they go through. It's all about scale, right? And you say you lose control, but do you ever really have control? I mean, if you think about that,
that's true.
You know, your employees are not necessarily anymore under your control from a production throughput process than a CM. There's certainly the perception, at least, that if it's your own employees, their allegiance and motivation is to make your company successful. And that's been true in my case, my experience. A CM has more conflicts because they have multiple projects and multiple customers. And I can see how that could cause some, at least perceived from the outside, from me as a customer, could be perceived as some conflicts that might not go my way every time. So,
would there be, like certification requirements? I mean, like, would the contract manufacturers have to have, like, ITAR, registration, AS9100 certifications, things like that?
So, fortunately, we personally have been able to avoid a lot of the certifications, but it's getting harder and harder. It's usually a requirement, and, for special circumstances, a unique tool like ours, agencies are willing to waive those requirements as long as you have something, that has some quality control system semblance to it. As we grow bigger and we start doing more volume, we're going to have to get those qualifications. And if we had a CM, they would have to have it. It's usually pretty easy, I think, though, to find CMs that have those because that's just part of their existence. And they are very process oriented. That's how they get the efficiency they need to offer the service at a price that you can afford. So, ITAR, our equipment per se has no ITAR restrictions, but occasionally fixtures that we design for customers to customize our product, their product is ITAR. So if we need those assets in-house to do testing, then yeah, we have to abide by ITAR restrictions on their parts. And in some cases, part of our solution may itself be ITAR restricted because it mates up with those parts. It's certainly customer restricted. I mean, I think on our Avid DT product, which is our desktop unit, we have about 60 fixtures designed. A few of them have been obsoleted. Most of them are open to the general marketplace, but several of them are designed specifically to work with a particular customer's part, and they would be of no use to anybody else.
Okay. I understand. So it sounds like you're doing a lot in terms of kind of educating the market. I mean, you're doing these talks, you're doing these research articles, research projects, and I think you go to a lot of trade shows. Um, how do you create that tipping point where a good portion of your potential market understands your product and sees it? You know, like that iPod, which was a brand new product to market, nobody even knew anything about it, but then all of a sudden everybody wanted it because they got it. Like, how do you move the
Yeah.
market to that point?
I wish I was half as smart as Steve Jobs, and I'm glad I'm a lot smarter than he was in some personal choices. Um, but it's tough. I mean, so if you have a product like ours that has a very niche market, it's almost the hardest thing in the world. It's good in the sense that it's hard for competition to encroach on you because there's a huge barrier in terms of investment in the product development that is going to be hard for a competitor to overcome.
Hmm.
The the other side of that coin, though, is there's a reason there's no competition always, right? And it's exactly what you said. People are used to doing things the way they've always done them.
Right.
Manual labor is the thing that we're trying to displace. And there are just some companies that even though they know they should be doing something in an automated fashion, there is a hurdle for them to overcome to get to that. There's
Hmm.
upfront capital costs are higher, long-term costs are lower, and they've got to get over that hump where they've invested and now they're reaping the benefit.
Right.
And so that's a hard sell. You know,
Right.
ROI based selling is hard because of the large upfront investment that's very different than the low cost manual tools, lots and lots of labor on the other side.
Right.
So, um, and
How
you know,
much?
it's the
How
old,
much? I know this would be hard to quantify because your different customers are going to have a different volume of production, a different number of ferals that need inspected. But like, do you have any way to quantify how much time, cost, um, you know, error cost, and human cost um, your product can save?
we definitely try to do that. It's always hard to get customers to give you their, the other side of the cost.
Right.
Um, I don't think I've ever been very successful at doing that, but there are a few cases where I have, and it it depends on the labor pool. For example, labor outside of the country is harder, so the volume has to be very high. You have to displace multiple people
Right.
in order to achieve the ROI. Where I know what we've done, we've saved a lot of money on each jet for aerospace project. Um, the case of Cisco, when we were working with them on the CRS-1 product, um, there was no way they could keep up with the demand using human labor. So they had a different cost. It was, we just can't do it, and we can't sell these multi-billion-dollar systems unless we automate. And so, but they also looked at how much labor they saved, and they were, well, I got to be careful what I say, but they were testing a lot of fiber every quarter,
Right.
and we were able to keep up with that volume. The other side you kind of know is I have a rough idea of what the throughput on a given instrument that we sell has to be in order to justify it on a pure cost basis.
Okay.
So, you know, let's take our Avid DT box. If someone told me they were doing 100 connectors a day, I would say, don't even think about this because you're not even close to, and I'm not saying the exact numbers right. But then you have someone who's doing 1 million cable ins a month. Uh, they need to automate.
Right. Right.
So there are rough rules of thumb. There are things. I mean, we also integrate cleaning into our inspection system. So the touch points is an issue. Instead of the operator having to go from inspect to a clean back to the inspect, we can do that all with one load of the parts from the operator. So there's a
Wow.
big savings there as well.
Yep.
Less potential risk. Another cost factor that you can use is we had a customer who was not lining up well on their outgoing inspection results to the incoming inspection. And we've been able to help customers reduce what I call supply chain friction, where by inspecting to something that is repeatable and reproducible, and we've been able to achieve 1 in a million reproducibility on outgoing and incoming inspections by properly guard banding and tuning the systems and not having people make decisions,
Right.
having a machine vision system make the decision, to the point where we've helped people drop from a 30% reject rate down to 0. That's
Wow.
a huge cost, because now on the customer end, the receiving end, they don't have to over order to make sure they're meeting their volume requirements for their
Sure.
production. Because if they need 100 parts and they have to reject 30 of them, and now they're only getting 70, they may have production delays as a result of that. So now they have to order 130 or 150.
Right. Right.
So it's a big cost factor. So we've helped customers do exactly that by using our equipment on both ends and tuning everything. They both agree on the outcome, and that's why I call it reducing supply chain friction, because they know it's going to flow from one step in the manufacturing process to the next with the right answer, and no finger pointing, and it's something they can quantify and verify.
Yep.
So.
Yeah, I mean, it sounds like for the right type of company, it's a huge win. And I almost think that in terms of getting this in front of a large percentage of the market, it seems like video has got to be the way to do it. I mean, you can only physically show up at so many places, right? So many trade shows. But if, you're already identifying what those customer issues are, and I would assume those people, whether they be engineers or whatever position they fill, they have questions that they might do some research on. And it seems like if you could be the one answering those questions in some videos, you could be getting a lot of eyes on this product.
Yeah, I have to tell you, I think of all the things that are being done in my company, the area where we're probably the weakest is marketing. Certainly marketing collateral. I constantly try to tweak presentations that I give, but every time I do it, I feel like it's a great pitch to an engineer, but
Right.
to someone who's making money decisions or making, broader programmatic decisions, it just doesn't have that, the right pizzazz. It's the only way I can address it. I
Right.
just I don't think I have the right mentality to document what we're doing, both multimedia, especially doing videos. And even the things I do know how to do, we haven't taken the time to convert to very short, focused videos. And, you and I have talked about this before. That's something I would like to do better. And I probably need to turn to experts like we create to help us with that.
Right.
Hope it's okay to say that during this.
No, yeah, it's fine. But yeah, obviously it's something we'd love to help you out with, and I do think that it could be your solution. And this is what I've seen over and over again, because the bringing a new product to market, something that the consumer has their own time tested way of doing things. They're comfortable with it. They factored it in, and then you have this revolutionary technology. The big challenge is always that education process. And really, when it comes to education, there's no tool that's better than video. And so
Yeah.
I really do think that could be a big thing for you.
Well, and to do the volume that you need to do, I mean, on the one hand, it's such a niche market, you would think, oh, it's pretty easy to figure out who all needs it. Well, it turns out it's not. There's a large number of companies, hundreds of companies, if not thousands of companies, that could potentially benefit from our tools in their manufacturing and support activities. There's no way I can talk to each one of those in an hour-long Teams meeting.
Right.
It's just not, I mean, I can't find them, and then there wouldn't be enough hours in the day for me to do that.
Right.
So we have done some videos. We've been interviewed at trade shows. We've done some of our own productions. But again, I think they need that right guidance of someone with the real artistic marketing eye, that persuasive scripting of what you say and do in the video that would be very helpful.
Right.
And then it becomes just okay, how do I let people know about this video so they can watch something for 90 seconds? And then if they want more information, do the 5 or 10-minute deeper dive, and then maybe contact you to get a demo or, in-person discussion.
Yep.
So I think our business could do better if we had better marketing, and video would be a big part of it.
Yep. Yeah, we
now,
could
the
all
flip side is our. Oh, I'm sorry.
We could all be doing better.
Oh yeah, you want to do better. If you get content with what you're doing, you're not paying attention. You want to be happy all the time, but you don't want to be content.
Right. I agree. Yeah, you definitely have to kind of be accepting of your current situation and be at peace with it. But yeah, always driving forward.
Yeah, Vince, I did some work with ESPN. I visited one of their new buildings to look at their fiber plant and see about helping them do stuff. Maybe we should edit out that they did that, but a major broadcast studio.
Yeah.
And they had some great quotes, and they had a Vince Lombardi quote that I've put on some of my presentations, and I'll paraphrase. I'm not going to say this is the exact quote, but he basically was given he was very famous for his pep talks, right? And he's talking to his players, and he says, look, we're going to strive for perfection. We will not achieve it, but along the way, we'll uncover excellence. And if you think about that and you make that part of your mission, just constantly try to get better, constantly try to be perfect, knowing you'll never get there, but you will continue to get better and better and better and eventually become excellent. And that's pretty good. So,
yeah, absolutely. And I think that's where a lot of people fall short, just being too comfortable with where they're at or not really willing to put the energy into even achieving excellence. It's hard.
And it gets harder and harder as you get closer, right? You got to put in more energy for that little bit of additional improvement, because the biggest improvements happens at the beginning where you're already messed up so bad that it's easy to improve.
Right. The old 80-20 rule.
Yep.
Yeah, I mean, it's great advice, and I'm super impressed with what you're doing. I really hope that you guys can have some really big breakthroughs in the market, whether it's on the commercial side or the military side. I'm confident you will. You're a driver, and you are not going to quit until you make it. So, very impressed with your mindset. So, Doug, tell me about your involvement in developing standards and really kind of guiding the industry when it comes to fiber optic inspection.
Yeah, so Nate, I've been involved in a couple of different types of activities. One of the groups I have worked with since 2004 is a group that does research on a lot of different topic areas in the optical space. They're involved in helping to define what is an acceptable level of contamination or defects on fiber optic interfaces. So they don't write standards, but they do research work that influences the standards. And so, for example, the work that I've done with that committee has resulted in the development of IPC standard for inspection and IEC standard. I'm working as a U.S. delegate to the IEC in a couple of working groups that define, again, the standards for inspection for different connector types. And in that regard, I'm currently leading a task force that is helping to create artifacts to allow for essentially calibration and better um, correlation of results across the multiple vendors that supply fiber in-face microscopes to the marketplace. We've published a number of papers at IWCS, for example, detailing our results and some artifacts that we've developed. My company has developed a number of chrome on glass artifacts, so that's one of the artifacts we're studying. A Ukrainian company, well, it's got a U.S. Company, but also engineers in Ukraine, has developed a different type of artifact, so we're evaluating that. So that's commercial. In addition, I've been on a commercial aerospace standards called ARINC. I'm currently not active in that, but I've been very active for several years in an SAE group called AS3, which is Mil Aerophotonics, and again, inspection and cleaning and other topics related to fiber optic connectors.
That standard is called AS3.
AS3 is the subcommittee within SAE that is aerospace standards.
Okay.
So it's the aerospace standards group, and I'm on committee number 3, which is fiber optics.
Okay.
So yeah, go
subsection.
ahead.
It's like a subsection of the AS 9100.
No, it's not. It's SAE, the Society of Automotive Engineers, but
Right.
we're doing aerospace things.
Right.
So it's broadened out quite a bit over its history. So it's a standards body, and I'm working on the committee, the subcommittee called AS3, that is dedicated to the fiber optics connector standards. So it's both the physical standards, the intermatability standards, the optical performance, and then the part my group, AS3, is primarily working, or my part of AS3, I'm a subcommittee chair on that, is supportability, which involves, inspection and cleaning and other things related to fiber optic connectors.
So I would assume that these roles and in the research and input that you're providing to the space is a little bit time consuming. What motivates you to do that? Is that you're just passionate about the subject and love talking about it, or do you kind of see that as a route to bigger exposure for your products? What are your thoughts?
Yeah, it's a combination of passion and, having the expertise that I can give back to the community at large. But a large part of it from a company point of view is it's a marketing. I consider that part of our marketing effort. I'm rubbing shoulders with end users. I'm rubbing shoulders with OEMs and cable manufacturers, like, on IEC. I'm not saying, anything proprietary here, but CommScope, Corning, other big players participate in these organizations. Microscope vendors participate, and then we've got end users who sometimes participate, especially like in AS3. We've got prime contractors like Lockheed Martin and Northrop Grumman and others who participate in these meetings. So you get to know and be known in that community, and I've been able to establish quite a reputation personally, and our products from Fiber QA have been recognized. There are opportunities to present technical data and, make pitches about the performance, not a sales pitch, but a technical presentation on the capabilities. And so it's got value in that regard. And yeah, I like data. So, it gives me an opportunity to design experiments and collect data, present the data. as we said at the beginning of this conversation, it's pretty clear I like to talk. And, I've been doing this kind of stuff for over 45 years, and I've given hundreds and hundreds of presentations, thousands probably, and some are to 3 people in a room, to 3,000 people in an auditorium. And I'm very comfortable doing it, especially if it's highly technical and work that I've done or, done with others. And
Yep.
I'm representing that group. So,
Well, yeah, it's impressive. I mean, just doing a Google search of your name, there's countless, papers and, different research that, committees that you've been on. I've seen a ton of stuff there. One piece of
hey,
advice.
yeah, if you want to share a list of them, I keep regretting that I'm not organized enough to have my own bibliography of things that I've co-authored or authored. So yeah,
Well, yeah,
it's a
there
lot of
there are
work.
out there. The one piece of advice I would have for you is when you're published, or somebody does an interview with you, make sure they're linking to your website,
Yeah,
because when it comes to search engine optimization, ranking for the terms that you want to actually rank for, those links are going to be absolutely valuable. And I see a notable absence of really good links to your website. So all these places that you're being published are huge opportunities to be getting those links. So just next one you
yeah,
do,
and I'm doing this much work and I'm taking this much advantage.
right, exactly. Yep.
Yeah.
So just a little tidbit for you. So yeah, I mean, it's
So
impressive all
I
that.
actually at one point I contemplated withdrawing from some of these standards bodies because, as you asked earlier, it is a very huge time sink. I mean, I I spent a lot of time, and some of the people who are involved in these committees work for large companies, and part of their title is standards.
Right,
So that's their thing, right? That's what they're paid to do. It's from my company's point of view, a minor collateral duty.
right, right.
Um, and yet I spend more time than most people on the committees because I am I get very involved. I have a lot of passion for it. I want the results out there.
Yep.
Um, so yeah, it's our website's a whole nother story, and I hope to be able to talk to you about that soon. But yeah, that's an area I'm weak in, and my company's weak in is our own marketing.
Yep.
Um, as an engineer, when you think about things, you think, oh, I just need to get some money so I can develop and design this product. But as a business owner, what you quickly realize is that's about a quarter to a third of the problem.
Mm-hmm.
The other 2/3 are sales and marketing.
Right.
And then the last third of the 4/3 is all the business stuff, the financial stuff,
Yep.
personnel stuff. Um,
Yeah, there's nothing easy about it, running a
no,
business.
not everybody would be doing it. Even politicians would try to do what we do.
An entrepreneur is the only one that'll work 80 hours a week to avoid working 40.
There you go. That's a good saying.
Well, Doug, thank you very much for your time today. I really enjoyed talking to you as always. You're a man with a lot of great insight and experience, and very impressive resume. So thank you very much for joining.
Well, let's see if I can go through the door to leave the conference room after all those praise. Don't put that in the podcast, but I've been very blessed to have a good career. I've been able to do a lot of different things. I've never been stuck in one little task or engineering discipline. I've had a combination of skills and ability to work hard to get there. I've had a lot of great people supporting me in all the efforts I've done that make me look good. It's just been a joy, and it is fun to somewhat be in control of your own destiny. I mean, entrepreneurs still have bosses. We just call them customers.
Right.
And It's been a great ride so far. Hopefully the next 10 or 20 years will continue to be great.
I'm sure they will.
Okay.
All right, Doug, thanks a lot. And thanks for joining us on Manufacturing Insiders.
Thanks very much, Nate, for having me on your show. Bye.